It's my video report and STS about the topic of NANO WORLD. NANO WORLD. NANO WORLD is the global market leader for tips for scanning probe microscopy and atomic force microscopy is sphere on influence of nanotechnology. NANO WORLD. The NANO WORLD represents the field in nanotechnology which focuses on structures and material that nanoscale 1 to 100 millimeters in the emerge as a global market leader, particularly in techniques like scanning probe microscopy and atomic force microscopy, which is essential for studying material and the scale. Nanotechnology influences various sectors, providing innovative solutions across industries such as electronics, medicine, and environmental science. Second, scanning probe microscopy, a branch of microscopy that forms image and surface using physical probe that scans the specimen. Founded in 1981 with the invention of the scanning tunneling microscope and instrument for imaging surface and atomic level. It is scanning probe microscopy. Here's the example and explanation. This is a microscopy techniques that creates image and surface at the atomic level using physical probe. This branch of the microscopy was pioneered in 1981 with the invention of the scanning tunneling microscope, which allows scientists to visualize surface and atomic precision. Third, atomic force microscopy. It is a type of scanning probe microscopy with the demonstrated resolution of the order of fraction of the nanometer more than 1,000 times greater than optical diffraction limits. The information is gathered by feeling or touching the surface with a mechanical probe. Atomic force microscopy is a specific types of SPM that measured surface topography with the exceptionally high resolution. It gathered information by feeling or touching the surface with a mechanical probe, enabling detailed analysis of material properties. Origin nanoscience. So, origin of nanoscience was discussed by the renowned physician Richard Feynman. His talk, there's plenty of room of the bottom, in which he described the possibility of synthesis via direct manipulation of atoms. In 1960, Egyptian engineer Muhammad Atala of the Korean engineer Dawon Kang at the Bell's lab fabricated in the first MOSFET, so which gate oxygen is 100 nm along with the gate length of 20. In 1962, Atala of Kang the nanolayer based on metal semiconductor junction transistor that use gold, then film, and the techniques of 10 nm. Origin nanoscience, the concept of manipulating matters that atomic level can be tracked by the Richard Feynman 1959 talk. There's plenty of room the bottom and can development the 1960s, including the fabrication of the first MOSFET and metal semiconductor junction transition lead the groundwork of nanoscience. Origin nanotechnology. The term of nanotechnology was first used by Norio Taniguchi in 1974. In 1986, Eric Dexter used the term of nanotechnology. It is a book engines of creation, the coming era of nanotechnology, which propose the idea of nanoscale, which the world are able to be build a copy of itself of other items of arbitrary complexity with atomic control. In 1980, the emergence of nanotechnology as a field into accurate through the convergence of the Dixler theoretical and public work. In 1986, Dixler founded the Fraser Institute to help increase public awareness and understanding of main explanation of origin of nanotechnology. The term of nanotechnology was first coined by the Norio Taniguchi and 1974. Eric Dixler further popularized the term of his 1986 book Engines of Creation, proposing the idea of molecular assemblers. Dixter also founded the Fraser Institute that promote awareness of nanotechnology, the nanoscience and technology. So nanoscience branch of science of the studies and system and manipulate matter on atomic, molecular and supramolecular scale, ultra small scale. The explanation of nanoscience and technology. Nanoscience is the study of the system and manipulation of the matter at the nanoscale. Nanotechnology applies this knowledge, focusing on the engineering of material and device of the molecular level to harness their unique properties. The nanotechnology. So the nanotechnology is the very diverse field that having bigger and bigger impact of the world, has the application in medicine, cars, spacecraft, food, electronics, and material science, just to name a few, refers broadly to field and applied science and technology, to unifying them, and this is the control of matter on the molecular level in scale smaller than 1 micrometer, normally 1 to 100 millimeter, and the fabrication of device within size range. Explanation of nanotechnology. Nanotechnology, this field encompasses the science, engineering, and technology involved in manipulating materials at the nanoscale. It impacts various disciplines including material science, biology, and chemistry, leading to advancement in multiple sectors. Nanometer. Nanometer, a unit of spatial measurement that is 90/9 meter or 1 billionth of meter. Commonly used the nanotechnology, the building of extremely small machines, nanoscale and nanostructure. Nanoscale and nanostructure. So what is the nanoscale and nanostructure? Nanoscale refers to the dimension at which material exhibit unique properties, leading to the creation of nanostructure that can behave differently than their forms. There's types of microscope used in nanoscience and nanotechnology. Electrons microscope. a microscope that used a beam of accelerated electrons as the source of illumination. In 1930, German engineers Ernst Rosca and Max Knoll built the first electrons microscope. So, utilize the accelerated electrons for imaging and was first developed in 1930. Atomic force microscope, types of high resolution scanning tube microscope that has the resolution that you can measure and fraction of the nanometer, was pioneered in 1986 by Nobel Prize winner Gerd Binig along the Galvin Kuwait and Christoph Garber. Scanning tunneling microscope, an instrument for imaging surface at atomic level, is a development in 1981 earned its inventors Gerd Binig and Heinrich Bonner the Nobel Prize in Physics in 1986. Possible application and nanotechnology in the Philippines. Information and communication technologies and semiconductors, health and medicine, energy, food and agricultural environment. And next, nanotech roadmap for the Philippines. So, information and communication technology and semiconductors, health and biomedical, energy, agriculture and food environment, health, environmental risk, nanometrology, education and public awareness. The next topic, nanotechnology and environmental benefits. So, improve detection and removal contaminants, development of finance, industrial processes and material concern high reactivity. And two, here's the explanation of nanotechnology and environment benefits. So, improve detection and removal of contaminants and development of sustainable industrial process that concern potential toxicity and environmental distribution without specific regulation. That's all, and thank you for listening in my report.